Hey everyone, we're going to be looking at stem and leaf plots today. You have already watched a video that constructed a stem and leaf plot from a data set. Now we're going to be looking at stem and leaf plots that are already constructed and looking at the measures of center, the measures of spread, and how to interpret the data and evaluate statements from stem and leaf plots. Before we begin that, I want us to go ahead and look at some constructed stem and leaf plots. One thing I want you to notice is that each of them have a key at the bottom. Sometimes it actually has the word key, like the first one, or it just has the box with the key inside. This is very important because this shows us the place value that's being used in the stem and leaf plot. Our first example says that the 2 and the O equals 20. That means that the 2 represents the tens place and the 0 represents the ones place. This is true for our second one, also for our third one. But if we look at the fourth one, this says the 6 and the 8 represent 6.8, 6 and 8 tenths. So that means that the 6 represents the ones place and the 8 represents the tenths place. So this is something you always want to check whenever you're looking at a stem and leaf plot. Now, another thing I want us to notice is on the third one here, we have a blank. Just like it was mentioned in the video, the stem is like a number line. And for this one, the number of sit-ups, 80 in the 80s was not a number that someone had for their number of sit-ups. But we have to include it because this is like a number line, so we leave that blank. We would consider that a gap in the data when we're looking at the shape. And another way to look at the shape of the data, sort of, is you can kind of trace along the numbers here to kind of see if is it evenly distributed, is it symmetrical. The only thing you have to remember though is that these are counting by 10s, 20s, 30s, 40s, and it's not counting by individual numbers. So that's something that you do have to keep in mind when thinking about the shape of the data. Okay, let's jump into the measures of center. Let's start with median. Now, stem and leaf plots are similar to dot plots in that you can take out or extract the data points from the stem and leaf plot. You can look at each individual number. So that's what we're going to do. We're going to go ahead and pull those numbers out, starting with our first number, which is 17, according to our key. So we're going to have 17, 17, 18. That's the tens. Then we have 20, 21, 25. That's our 20s. And then we have 30, 30, 30, and 33. That's our 30s. So we should have 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And once you have them in order from least to greatest, you can go ahead and find the median. What is the median of this data set? Okay, we're going to go ahead and use our strategy of marking off the lowest, highest, all the way to the middle. And because we have an even number of data points, we have two numbers in the middle here for 21 and 25. So we can add these two together, 21 plus 25. We're going to find the mean or the average of these, 46. 46 is an easier number to divide by 2 because both digits are even, which means 4 divided by 2 is 2, and 6 divided by 2 is 3. So our median is 23, which is also directly in the middle of 21 and 25 if you were to put it on a number line. Okay, now for the mean. Based on the data points we have here, what do you think the mean of this data set is? Okay, you find the mean the same way we always have. We're going to add up all the data points, all 10 of them, plus 25, plus 30, plus 30, plus 30, plus 33. I would not recommend adding all these up at the same time. I would add 2 at a time until you get your total. Your total should equal 241. And because there are 10 data points, we're going to divide that by 10. And that gives us 24 and 1/10. Now, this mean and this median makes sense. They're both close to each other, and they're both in the middle because the 20s are in the middle of our data set up here. So this makes sense. And because the data is fairly symmetrical and fairly evenly distributed, this also makes sense that our median and mean are pretty close to the center there. Okay, moving on to measures of spread. Now, just looking at the stem and leaf plot, I'm going to go ahead and ask you, what do you think the range of this data is? Now, we don't even have to list out the numbers to find the range. We need to look at our first number here, which is 17, and our last or largest number here, which is 33. And we're going to subtract those. 33 minus 17 gives us 16 for our range. That's the space between the smallest and the largest number. Another good thing about stem and leaf plots that's similar to dot plots is that they're already in order from least to greatest. They're already in order, which helps us out a lot. Okay, now for the interquartile range. We're going to go ahead and list out our data points again. 20, 21, 25, 30, 30, 30, 33. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Okay, now we already did the first step of finding the interquartile range. What was that first step that we already did? In our previous slide, we had already found the median of this data set, which was directly between 21 and 25, and that was 23. Now we're going to find the median of the lower half and the upper half like we've done before to find our interquartile range. So for our lower half, our median is 18, which is Q1, first quartile. And then for our upper half, our median is 30, which is our third quartile. Now to find our interquartile range, we need to subtract our third quartile and our first quartile, which is 30 minus 18, which gives us an interquartile range of 12. Okay, that was our spread. Now let's look at some interpretation questions. I wanted to add a slide on this because these are the most common types of questions that you're going to answer from a stem and leaf plot. So I've put two questions here, and the first question is, how many dolphins ate more than 20 pounds of fish, according to this stem and leaf plot? Okay, they want to know how many ate more than 20. Okay, so when we look at these numbers, we're looking at numbers higher than 20. And so some people want to include the 20 here, but it says more than that. So we're actually going to start with 21. 21, 25, 30, 30, 30, and 33 are all higher or more than 20 pounds of fish. So that means we have 1, 2, 3, 4, 5, 6. 6 dolphins ate more than 20 pounds of fish. If this was a multiple choice question, they would definitely have the number 7 listed because most people would want to include that 20 right there. Okay, our next question. What is the most common number of pounds of fish eaten by a dolphin, according to this stem and leaf plot? Now, when you first see the word most, some people may jump straight to the end, 33, and think, oh, that's the most, that's how many. But it says the most common number. The most common means it shows up the most. Another word for that is the mode. So that means that we're going to look at our leaf section and look for ones that repeat. So the only ones that repeat, we have 2 17s here. But for 30, we have 3 of those. So that means that 30 is the most common number of pounds of fish eaten by a dolphin because 3 dolphins ate 30 pounds of fish. That's more than any other dolphin from this set of data. These are your most common questions you're going to get. And my advice to you is to make sure and read each statement, because sometimes you may have several statements to read, and evaluate them one at a time. Okay, that's it for stem and leaf plots today.